Alrighty, let's get started. This is video 625. And I will just mention right now, if you hear some rattling in the background, that would be my co-host. You can see her. Oh, that would be my co-host. All right, that's just her butt. There she is. Hello, Jelly Beans. All right, back to work. I hear that's a thing everybody does on Zoom is they have their pets, and she is way too big to put in my lap. So every once in a while, I just a little bit of Jelly Bean. Okay, this is 625. It is the second word problem. So let's check it out. Emma Lou is buying pizza and cookies for a party. Pizzas cost $9 and cookies are $5 a pound. Emma Lou wants to spend no more than $50, but she needs at least 3 pizzas and 2 pounds of cookies. Use inequality in a graph to see how many of each item she could buy. So number one thing you always look at is, what do you actually have to figure out? What's the question asking you to do? Well, it kind of gives you a hint there. We want to know how many of the cookies and how many pizzas she should buy. So P, number of pizzas to buy. And C is pounds of cookies. Now this question's a little more in-depth than some of our other ones, because first of all, we're talking about money. And that's really a common thing with the linear inequalities is, you know, you have the stuff you got to buy and there's so much and you have amount X for budget. So the first thing we can get is every pizza. So it's $9 for a pizza plus $5 for a pound of cookies. And she doesn't want to spend more than $50. So less than or equal to 50. Okay, so that's that part. But what about this? She needs at least 3 pizzas. So my pizza needs to be greater than or equal to 3. Exactly. And my cookies, at least 3 pizzas and 2 pounds of cookies, greater than or equal to 2. So there's actually 1, 2, 3 different equations we have to worry about. And you know what, that's all we really need to worry about now. I'm going to convert these so you don't have to. I just find it easier. So make this equal X and equal to Y. So 9X plus 5Y is less than or equal to 50. And PX is greater than or equal to 3. And Y is greater than or equal to 2. All right. So this is going to be kind of the biggest part of our graph here because it's got a 50 on there. So let's start with that one. You know what, in general, I just start with the more complicated looking equation. It doesn't really matter, you can start with any of them. So it's my X, and I got 9X plus 5Y is less than, whoopsies, I keep doing that. Make it an equality when we draw the graph, because we want the border. All right, now, because it's 50 there, you know what, I'm gonna start, I don't know, how about 5? Big number. So 9 times 5 plus 5Y is equal to 50. 9 times 5 is 45 plus 5Y is 50 minus 45 minus 45. That should give me 5Y is equal to 5. So Y is equal to 1. I think if I use 6, I'm going to end up with some negative numbers. So I really don't want to do that. So I'm going to go with 4. 9 times 4 plus 5y is equal to 50. 9 times 4 is 36 plus 5y equals 50 minus 36 minus 36. 5y equals, I don't know. Okay, I'm lazy. 50 minus 36 is 14. So y is equal to 2.8. What do you think? 3. All right, so 9 times 3 plus 5y is equal to 50. 27 is 50 minus 27. D minus 27 is 23. All right. Oops. Just kind of lost a little bit there. But the same process is the same, so 4.6. All right. So when I set up the question, I gave us this big graph paper because I thought with the number 50 in it, we're gonna have really big numbers, but they're actually not bad. So it's like my biggest X right now is 5, and my biggest Y is like basically gonna be 5 too. So I'm actually gonna do this. 1, 2, 3, 4. You could make them each one or whatever you want. I just think that's going to be not a bad scale for us. I could have went bigger. All right, now let's go back to our original equations. Oh, look at this. All of them are that have the equal to part in them. So all of these are going to be solid lines. That makes it easier. Excuse me. So 5 over, 1 up. 4 over 2.8. Okay, well, there's 2. That'd be 2.5. So about there. And then we got 3 and 4.6. So there's 4, 4.5, and a little bit more, 4.6. And they are indeed in a lovely straight line. So that's kind of cool. And that's equation number 1. 9x plus 5y less than or equal to 50. Now, I don't think you guys have done enough. Which side do you think it is? Is it going to be this side that's going to be less than 50? Or this side that's going to be less than 50? Yeah, me too. I agree with this one because I already know that if I buy nothing, that's going to be less than $50. But that's not good enough. We got to do our checkpoints. Checkpoint number 1. I'll do my usual 0, 0. All right, now I need my equation. 9x plus 5y is less than or equal to 50. 9 times 0 plus 5 times 0 less than or equal to 50. 0 is less than or equal to 50, which is what we thought was going to happen. So this side's good. Now let's go 5. Oh, it's just easy. 5 and 5. Always, 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 always do 2 checkpoints. So 9 times 5 plus 5 times 5 is less than or equal to 50. I don't know, but it's not. That's 45 plus 25. It's already too much. Oh, it's going to be 70. It's less than or equal to 50, which is like no. So this is no. Yeah, I'm going to fess up to you guys. By skipping boxes, you know what? Hold on. Because we can't buy a partial pizza, I'm only allowed to have whole number answers, actually natural numbers. So I can't use these lines in between, so I'm just going to be lazy here. And we'll just ignore those lines in the background. Okay. If you were clever and made one box equal to one of them, then this won't be an issue. Okay. With me? All right. So getting back to, we are buying pizzas and cookies. And we're going to assume, although the question doesn't say anything about having to buy a full pound of cookies, we're going to assume we have to buy a full pound of cookies. And it also says she needs at least 3 pizzas and 2 pounds of cookies. So we might as well go with natural numbers on this one because there has to be more than one. So natural numbers are basically, you do like that. And you can't include the axes. So first quadrant underneath the line. And then I'm just going to do this. Yeah, it looks like there's one there. Okay. So this has got to do with the money factor. Now we need to look at the P, pizzas, where X has got to be bigger than 3. So if we want to graph X, this was number 1. Switch to a different color. So we're going to do number 2 here. And we got X is greater than or equal to 3. Now, if you remember from before, this is one of those lines that says they're horizontal or vertical, and it's going to cross the x-axis at 3. So here's my x-axis. There's 3. So when you have only one variable, you don't have to draw the chart. I personally just find it confusing. Oh, can you guys tell the difference on the screen that this is green? So this is line number 2. So this is x is greater than or equal to 3. Now we need to do our checkpoints. All right, so I'm going to pick that point right there. And that is 2 and 4. And it's x is greater than or equal to 3. And there's a 2 there, greater than or equal to 3. And that's like no. So this is wrong. So let's pick one on the other side. No, 5 by 3. X, no, CP2. I'm getting tired of writing checkpoint. And we're going to do 5 and 3. So X is greater than or equal to 3. So 5 is greater than or equal to 3. And that part is right. So this side is cool. So now we want to look at, I'm going to circle these. Okay, so right now I can see my solution set is stuck in that little triangle there, but we're not done. We have, wow, I really hope you can't hear my dog basically throwing up beside me. We still have number 3, which is y is greater than or equal to 2. So that means it's going to be crossing the y-axis at 2 because we're plotting y is equal to 2. So this is my axis and this is the where. So there's 2, my y-axis. That's line number 3. Y is greater than or equal to 2. And now we need to do our checkpoints. Oh my, that was my dog. That was not me. I'm sure that's showing up on, or you can hear that. All right, let's see. Yeah, this point will do. And it is 5 over and 1 up. And our equation is y is greater than or equal to 2. And 1 is greater than or equal to 2. Nope. So this one is a nope. Whoops. No. And then we need to do something on top of the line. No. Let's use that one, which is 5 over and 4 up. So we got y is greater than or equal to 2. 4 is greater than or equal to 2. So this one is okay. So you got that? I'm sure what, I guess it's my pen. So our feasible area. Oops, I forgot to do some coloring. Here, and here, and here, and here, because you can do on the line. So, all right, guys. We have to be underneath this line. So like that. We have to be to the right of this line and above that one. So after all that work, that little bitty triangle is our feasible solution. Okay, so let's take, for example, let's check our work. All right, so that is the coordinates 3 and 3. Let's see if it answers all our questions. First of all, are we spending less than 50 bucks? So pizza, we got, 3 of them, and each pizza was $9. and cookies. We're getting 3 pounds, and each pound of cookies was $5, and that's $15. So if we add that up, I don't know what it is, but I don't think it's over 50. 27 plus 15. All right, so that's $42. So that answers the part about sending less than $50. It says she needs at least 3 pizzas. Check. We have 3 pizzas, so at least it works. And we actually have 3 pounds of cookies, and it says we need at least 2 pounds, so it fits. So when you're doing a word problem, you can go back and check your equations, but it's a much better idea to actually go back to the original question and see if everything that is in there fits. Okay, and I just pick something in our solution set, our feasible region, so anything that's in that triangle. There's not a whole lot of options. It's kind of like this one, this one, this one, this one, and this one. Okay, but any one of those looks like 5 points would work. And you can check it. And that's the end of that one.